Welcome, everybody. For our first time listeners, my name is Jack, and it's nice to have you join us. For my return listeners, I want to thank you for your continuous support. Today, I have an interesting topic that I want to share with you. It is about one of the most peculiar objects that astronomers have ever identified. This is the interstellar object called Oumuamua. Here is an artistic rendition of Oumuamua, which was identified about 2 years ago by a group of astronomers that were surveying the skies for meteors and asteroids and comets. And what they came across is this interstellar object that had very, very peculiar properties. Now, this has baffled astronomers and amateur astronomers for the last couple of years, mostly because we have no idea as to what it actually is. There are a few theories, one of which is posed by Dr.Loeb of Harvard University. He actually is making the claim that Oumuamua might be an extraterrestrial solar cell. Now, this is a bit outside of the box thinking, but I'll get into it in a little bit more in a little bit as to why he is adamant about his idea of what Oumuamua actually might be. So Oumuamua, as you might be able to tell here in this very small blurb, it's an object that's traveling through the interstellar space and into our solar system. Now, the problem with Oumuamua when it was discovered in 2017 by the Pan-STARRS survey is that by the time the astronomers identified this object, it had already traveled so far out that it was almost impossible to get images of Oumuamua. Therefore, the only blurry images that we have are the reflections of Oumuamua that we get. In other words, the sun, when it hits Oumuamua, the reflection is all that we were able to capture as it was traveling through our solar system. Therefore, the images are not clear and we don't have any direct images. So here is another rendition of Oumuamua, but this is essentially a guesstimate of what we think Oumuamua can potentially look like. Although there was limited imaging, the astronomers were still able to piece together some of the data that they were able to capture to come up with some of the characteristics and features of Oumuamua. And if I may add, some of these characteristics are very, very interesting and peculiar, and they are different than anything we've seen so far in outer space. Now, here we could see Oumuamua as it's entering our solar system. As it enters our solar system, it essentially passes through the sun where it gets a kick in its speed, and as it travels outside of our solar system on its way out. Now, this trajectory of Oumuamua is very different than anything we have seen before. And one of the reasons why it's so interesting is that this is one of the first interstellar objects that we've been able to pick up. In other words, it's an object that doesn't originate from our solar system and comes from outside of our solar system. It enters and then goes right out. The other feature that astronomers were able to piece together is that when the light reflected from Oumuamua was recorded, what they were able to see is that the light had this rhythmic sort of oscillating pattern. As you could see here, it where the top of the dome is higher reflection and the bottom is lower. In other words, when we put all of this information together, it looks like Oumuamua is actually tumbling while it's traveling through the interstellar and within our solar system. Now, this tumbling is very interesting because it's not tumbling in a random way. It has specific rhythmic oscillations which make it very, very interesting because most objects in space, asteroids or comets, are not really tumbling in this rhythmic oscillatory pattern. So this makes Oumuamua very, very, very interesting. Now, if we were to put all of this together and get sort of an artistic rendition of what Oumuamua will look like, we will see that in this next video, is potentially a long, elongated, cigar-like object that is tumbling through the interstellar space in this rhythmic motion as it's traveling towards our solar system. And as it gets near our solar system, we see that it continues to maintain that tumbling motion. And again, most of these are projections of what we think might have happened as Oumuamua was entering our solar system. So we see here Oumuamua entering the inner solar system, passing through the sun, where it gets a kick in its speed and it goes out of our solar system. Now this speed that it picks up, or the kick in its speed and the acceleration, is in itself very, very interesting, because if we were to take two large objects and we bring them close to one another, their gravitational pull will cause an acceleration in each of them and cause them to speed up essentially. And this is what normally happens to objects that are traveling around the sun. They'll pick up essentially a kick from the gravitational pull of the sun and therefore accelerate. But if we were to look at the acceleration of Oumuamua, what astronomers were able to calculate is that the gravitational pull of the sun wasn't enough to account for all of the acceleration that Oumuamua had. This suggested that there must be an additional phenomena. And Dr. Loeb from Harvard is making the claim that if we consider Oumuamua to be a solar cell, then the light reflected off of Oumuamua, essentially the radiation coming from the sun, will cause Oumuamua to pick up more speed. So Dr. Loeb, who is the chair of astronomy at Harvard and the director of the Institute for Theory and Computations at the Harvard-Smithsonian Center for Astrophysics, has a very peculiar and very outside of the box thinking as to what Oumuamua might be. So when he looked at all the data that was collected by the astronomers during the brief period that they were able to observe Oumuamua, he was able to come up with 6 essentially peculiarities that separated Oumuamua from everything else that is known in the field of astronomy. The first thing that he was able to identify is that Oumuamua is suggesting that there has to be interstellar objects that are far greater than expected. In other words, if we were to expect objects like Oumuamua to be very common, then the calculated interstellar objects that we observe would be a lot greater than what we currently observe. And this is essentially going against the idea that Oumuamua is a very common object that we just haven't been able to pick up. In fact, his calculations suggest that Oumuamua is a very, very, very rare object. In fact, it's in the order of 1 in a billion, essentially. The other thing is that the Oumuamua, it looks like it's almost like a buoy sitting on top of the surface of the ocean, and he's proposing that there are multiple such buoys spread throughout the interstellar and stellar space, and that these act as relay stations or road posts. Now, exactly for what, it does not go into detail, but one can essentially extrapolate from these is that if he makes the claim that these are interstellar extraterrestrial solar cells, then it could be that they have these solar cells that are essentially communicating with one another. The third is that the dynamical origins of Oumuamua is extremely rare. In other words, the speed that it picks up from the sun and the trajectory that it follows is something that is not found in anything that astronomers have observed so far. Fourth is that the the shape of Oumuamua is very peculiar, being very flat and very elongated, almost like a flattened out cigar shape. And this is something that is not seen in asteroids previously. And fifth is that Oumuamua was unusually shiny, which is why he suggests that Oumuamua could potentially be a solar cell. And this shininess is 10 times higher than anything observed in our solar system in terms of asteroids. And finally, the sixth peculiarity is that the trajectory that Oumuamua deviated, essentially the kick that it got from the sun, has to be something that is more than just the gravity of the sun alone. So when he put all of these together and he went down the list of the potential objects that he knew that Oumuamua could be, he pretty much crossed out everything that was known. And the only thing that was left was that it's potentially a solar cell. And as Dr. Loeb likes to quote Sherlock Holmes, in which Sherlock Holmes states that when you have excluded the impossible, whatever remains, however improbable, must be the truth. And therefore, once he's ruled out all the possibilities of what Oumuamua can be, he's only left with one possibility that he cannot rule out. And this is that Oumuamua is not an active comet, but is actually a light cell or an extraterrestrial origin of some object that was made to specifically traverse through this interstellar space. Now, he's not making the claim that this is an alien spacecraft, but he's also not flat out denying it. He's suggesting that this is something that we have not found in our solar system. It has very peculiar properties, and if we removed everything that we know Oumuamua could be, we are only left with this potential option that it is a light sail of extraterrestrial origin. By light sail, well, if we look at Oumuamua, it has a very flat and elongated shape, and light sails would be built according to this structure essentially. A light sail would be a flat object that is able to reflect the sun's rays, and when it reflects the rays, it gets a boost in its speed and is able to travel through space. Essentially, one can think of the sun's rays as a bunch of ping pongs that are hitting the sail, and every time they hit the sail, they push the sail forward. So if we imagine Oumuamua being this kind of a ping pong board where the sun's rays are pushing it forward, then this could account for the extra kick in its speed that it received as it was moving through the inner solar system and passing through the sun. Now, putting all of this together, one conclusion is that Oumuamua is something we still don't understand, to be frank, and there are still continuous studies that are being done to see whether we could pick up such objects in space. Now, Oumuamua might be the first one that we've picked up, and it could be the case that up to now we've only been able to observe one of such species of objects because we've been pointing our telescopes in the wrong place. And now that we've seen one of these objects, maybe we can point our telescopes in the proper direction of the sky and be able to pick up more of these species. Now, these are studies that are continuously ongoing and will be exciting to follow up with. Now, as Oumuamua is tumbling through its journey, people are continuing to be baffled by this, including myself. So I reached out to Dr. Loeb for an interview for this presentation, but unfortunately, due to contractual obligations for a book that he's writing, he could not do this interview at the time. but he said that he will be more than happy to do this in the very near future when the book is completed. So please look forward to our future interview with Dr. Loeb, and I'm excited to not only read his book but also to meet him in person and discuss what his theories are about Oumuamua and whether it has changed since the initial observations were made. So hopefully you guys have enjoyed this presentation and it has tickled some of your curiosity. There are a few online websites and YouTube's videos of Oumuamua. If you're interested, please go have a look. I think it's a very fascinating topic, and it's something that I will be paying more attention to in the near future for any developments, and will continue to update you guys. And with that, I want to say thank you to all of you, and if you have any questions, please feel free to drop a comment below, or if you have not signed up for my YouTube channel, please go ahead and hit that button. Any feedback would be much appreciated, and if there are any topics that you guys are interested and would love to have me make a presentation, please feel free to also drop a comment. With that, I want to thank you all once again and wish you a wonderful day.